Hello, today's lesson is over volume of prisms. So before we start, I'm going to jot a few things at the top of the notes just to review what a prism is, because that's going to be important in this lesson. So if you remember from the beginning of this unit, a prism had two, I'm going to put that in capital letters, two bases. And then the rest of the figures were rectangles. So I'm going to put two bases and rectangles. So if you had a triangular prism, that means your two bases were the triangles and they were connected by rectangles. If you had a trapezoidal prism, that means your two bases are trapezoids. If you have an octagonal prism, your two bases are those octagons. So that's important to know what your bases are. Remember, I told you guys over and over, base does not always mean bottom. The bases of your prism are those two shapes that give the prism its form, or the two shapes that you would name the prism by. So we're going to do volume of a prism. We'll talk about what volume means for a second, but I'm going to go ahead and give you that formula. The formula of any prism where you have two bases and rectangles is A times H. The reason I am bringing up the basis part, because it's so important. When I say A, that's area of the base. That doesn't mean area of the bottom. That means area of whatever your shape is that gives it its base. The height is the height or the length. It could be either one of the prism. And it's always like the distance between those bases. I'm saying height or length because it's important to realize if your base is not always on the bottom, that means sometimes your prism is laying on its side. And if your prism is laying on its side, then the height might not be up and down. It might actually kind of serve as the length. So we'll talk about that as we go, but that is super important to know that a prism has two bases and you have to know what those bases are. So volume, the volume of a prism is the amount of three-dimensional space that it takes up, and it's denoted in cubed units. It's kind of like how many cubes could I fit in something. I told you guys, if you had a Christmas present, volume is like how much you could fit in the box. Surface area is like your wrapping paper. So volume of a rectangular prism, these are like a box, okay? These are the easiest ones to find. You have done this before. It's length times width times height. Now, this is different than the formula I just showed you in a way, but really it's the same thing because in a box or a rectangular prism, your base is a rectangle. And to find the area of a rectangle, you take length times width. So this is the same thing as area of the base times the height, the exact same thing. But anytime you have a box, length times width times height should be the easiest volume to find. So, in example A, this would be kind of your length, this is your width, this is your height. All you gotta do is multiply them together. It doesn't even matter what order you do this in. You just take your three dimensions in any order that you please and you multiply them together. So I'm typing that into my calculator, and that is 3,672 centimeters cubed, because I took centimeters times centimeters times centimeters. So that's how many cubes that I could fit into that figure. Same thing here. Take your length, width, and height, your three dimensions of your box, and multiply them together to find the volume. 10 times 14, that's kind of like the area of the bottom, times 4.5. And I'm going to type that in. 10 times 14 times 4.5 is 630, and this one is in inches cubed. So let's talk about other prisms. Like I said up above, any prism is going to have two bases, and those two bases are going to be connected by rectangles. So in this figure, this is a triangular prism. We practiced naming those before. So that means your bases are the two triangles. And to find the volume of a prism, you take the area of that base. So notice this shaded area, it says A. You take the area of your base and you multiply it by the height of your prism. One way to make some sense of this, if you find the area of that highlighted shaded section, that's two-dimensional. But if we want volume, we want that third dimension. So you take that flat area and you multiply it by that third dimension, which is the height. I'm going to actually draw this picture another way. So as I said before, your triangles are the bases. If I just took this prism and I turned it on its side to where it looked like this instead, that shouldn't change the volume. These are still the bases. So I'm going to label that, and you can pause this at any time to kind of catch up with your writing. But that is now the area of my base, the front. And then my height, this is real weird. The height of the prism is also still the same measurement, but notice it's not up and down anymore. Now it's kind of like the length. Okay. So just to reemphasize, write this down with me and you can pause. A means area of base shape, which is not always the bottom. And then the height, again, it's not always up and down. Sometimes it's on its side. So I'm going to put the height as the distance between the bases. It's whatever gives it that third dimension, whatever takes your flat area and extends it. Distance between bases. All right. Pause if you need to finish that, but I'm going to move on. Pause this at any time. All right, example A. So example A is a triangular prism. So that means when I go to do my volume and I find A, or the area of the base, I should be finding the area of a triangle. You will be given a formula sheet on your test, but the area of a triangle is 1/2 base times height. This is triangle. So that's what I'm finding first. I'm just going to find the area of my base or the area of the triangle. I'm going to kind of highlight this. This is the area that I want to find. Now remember, when I do 1/2 base times height, I want my base and height to meet at 90 degrees. So I'm not actually going to use that 9 as my base. I'm not going to use the 9 because it does not meet at 90 degrees with my 7.3. However, I can use this 12 right here, that 12 feet. The 12 and the 7.3 do meet at 90. So that's my base and height of the bottom triangle. So the area of that triangle is 1/2 times 12 times 7.3. That would be the area of my base. So 12 times 7.3 divided by 2 is 43.8. I have my A. Now, that is a flat two-dimensional area. To find the volume, I have to take that flat two-dimensional area and multiply it by a third dimension. If you look at my color coding here, look at this 5 feet. That 5 feet is like the height of your prism. It's going to take that area, that flat bottom, and extend it upwards. So that's my third dimension. So I'm going to take my area times 5. Okay, so 43.8 times 5 is 219, and this would be feet cubed. Now, I like that A and B are paired together because both of these are triangular prisms. So that means both of these have bases of triangles. However, A, the triangle was on the bottom, but on B, the triangle is in the front. So it's kind of like it's turning the prism on its side. This is now your base. The base is the triangle still. It's not the bottom. It's not the rectangle. So when I go to find the area of the base, it's going to look the same. I'm going to use 1/2 base times height because I have another triangle, a triangular base. So I'm going to do 1/2 times 11 times 5.4. That's my 1/2 base times height. Divided by 2. All right, I am getting 29.7 as the area of my base. That's just the area of the highlighted figure. Now, think about this for a second. That's flat, it's the flat highlighted area. Think, what is going to give that triangle a third dimension? What would the height or the length of the prism be? Well, since the base is not on the bottom, that height is actually laying on its side. So if you look at this, 16 millimeters. That's like the length or the height of your prism. It's going to give that flat figure its third dimension. So I'm going to take my area that I just found, and I'm going to multiply it by 16 times 16. That's going to give me 475.2 millimeters cubed. If you think you have this and you know how to find the area of a trapezoid, now would be a really good time to pause and try this. If you're not comfortable yet, that's okay. But this next one is a trapezoidal prism. So what that means is the area of my base should be a trapezoid. So if you look at the picture closely, the base is not on the bottom. This is your base right here. This right here is called a trapezoid. Everything else is a rectangle. So when I go to find area of the base, or A, I'm finding the area of a trapezoid. Area of a trapezoid, this formula will also be on your reference sheet for your test. It's 1/2 times the height times base 1 plus base 2. A trapezoid has two bases, and it's always the parallel sides, usually the top and bottom. So I am only looking at the highlighted part of my figure, the trapezoid. The height of the trapezoid is that dotted line, which is 17.9. The bases of my trapezoid are the two parallel sides, the top and bottom side of my trapezoid, which happen to be 36 and 14. This is going to find the area of that trapezoid for me. So let's do that. I'm going to do 36 plus 14. Let's see, times 17.9, and then I'm going to divide it by 2. 447.5. There's the area of my trapezoid. And then again, ask yourself, if that is a flat area, what is going to give that flat area its third dimension? The height or length of the prism would be this dimension right here. And if you look closely, that dimension is 25. Again, since the base is not on the bottom, the height is going to be on its side. So take your flat area, which is 447.5, and you're going to take it by its third dimension, which is 25. I still have that on my calculator, times 25. And it's 11,187.5 meters cubed. Now, a cylinder. So I stuck cylinder in with a prism for a reason. Now, a cylinder is not technically a prism. So if you remember what we talked about polygons, a circle is not a polygon. However, a cylinder and a prism have a lot in common. A prism has two bases. A cylinder also has two bases that are circles. And we just talked about how the volume of any prism is area of the base times height. This is really no different. Area of a circle is pi r squared. So you're doing the same thing. You're finding the area of that base, finding the area of the circle, and then you're going to multiply by the height of the cylinder. Remember, height is not always up and down. Sometimes the cylinder might be on its side. So this is as easy as taking your two parts, your radius and your height, and plugging it into the formula. We'll round to the nearest tenth. So I'm going to do pi times 18 squared times 15. rounded to the nearest tenth. That's what that looks like, inches cubed. Now, this one is like if you took the cylinder and turned it on its side. So if you took the cylinder and you turned it on its side, please pay attention. This is not the height. No, okay? Since it's on its side, the height of the cylinder, or the distance between the bases, is this right here. Your radius would be this right here, which is half of 11, 5.5. So my radius is 5.5, my height is 21. Plug that into your formula and you will have your answer. Easy as that. You will be given the formulas on the test. $1995.7-ish. There you go. If at any time you have a question, please raise your hand and I'll come answer your question. Thank you for listening to this video all the way through. And I am here if you need help.